Okay, welcome to this seminar. My name is Per Molander. I live in Uppsala, Sweden, and I have a mixed background in physics, mathematics, and social sciences. Today's seminar is about voting theory, and the lecturer is Professor Hannu Nurmi from the University of Turku in Finland. To those who are acquainted with the field of voting theory, Hannu Nurmi is a well-known name. Held the chair of political science at the University of Turku until his retirement in 2012, and he has been professor emeritus since. Between 2008 and 2011, he was the director of the Center of Excellence of Public Choice Research at the same university. He's also been a member of the Finnish Academy of Sciences and Letters since 1982. He has published more than 200 articles in scholarly journals, 14 books as an author or co-author, and he has co-edited 6 books, not only in political science, but also in economics, philosophy, operations, research, and fuzzy systems. I made Hannu's acquaintance back in the 1980s when he lectured on voting theory during a summer course in Oslo. And I have had the benefit of consulting him on several occasions since. We engaged him in a constitutional project in Stockholm some 20 years ago, which resulted in the book Voting Procedures Under Uncertainty. And more recently, I got some support from Hannu in a small reform project in the Swedish Academy of Sciences, where I managed to convince my colleagues there to switch methods for electing new members from simple plurality to the border count. Now, the topic is voting theory. We vote a lot in democracies. We have general elections, vote in parliament, in shareholders' meetings, and civil society organizations, and so on. But very few people are aware how intricate voting theory really is. Voting theory is a branch of applied mathematics that has been developed to fill this lacuna, starting in the late 18th century with names such as Condorcet and Borda. The basic question is, how do you select a winning alternative from a set of alternatives in a large group where people have different opinions? What is the best procedure? And unfortunately, the main message from this body of research is negative. There is no best procedure. When there are only 2 alternatives, the choice is easy, because we choose the alternative that has the greatest support, the majority, and if there is a draw, 50-50, we draw lots. But if there are more than 2 alternatives, the situation becomes much more tricky. There has to be some sort of compromise, and there are basically 2 ways of thinking about this compromise. One is to imagine a series of pairwise contests between the alternatives, like in a soccer league. And if there is one alternative that is victorious in all these contests, that will be the winner. A second approach is to let everybody rank all the alternatives and then form some sort of collective ranking on the basis of those individual rankings. Both these approaches have their problems, and they are sometimes even in conflict with one another. This was discovered by Condorcet when Borda submitted his procedure to the French Academy of Sciences in the 1780s. Borda's suggested procedure, simply adding the rankings of the individuals, will not necessarily select a winning alternative according to Condorcet's own criterion. On the other hand, a problem for Condorcet's criterion is that there is not always such a winner, what we now call the Condorcet winner. Now we know from other fields, whenever there is no obviously best procedure, whether in politics, religion, or arts, fractions tend to develop. This is true also for voting theory. Although, as far as I know, no voting theorists have killed one another because of differing opinions. One tradition has followed the Condorcet track and raised the Condorcet winner to the status of a norm. And when there is no Condorcet winner, try to find some approximate solution which is as close as possible to a Condorcet winner in some suitable metric. The other traditions focused on rankings and developed various methods for mapping individual rankings into some collective ranking. A number of improvements have been suggested in this original debate between Condorcet and Borda, but no definite winner has emerged. So in today's lecture, Hannu, in a true ecumenic spirit, will try to bridge this gap between the Condorcet and the Borda traditions by penetrating the concept of a winner. So we look forward to this peacemaking operation. Hannu, the floor is yours.
Thank you very much, Per, for these kind words, and you already covered much of what I'm going to say, but I'm still going ahead with my presentations as well. I think we have seen this first slide now, so we can go to the next one. Thank you. So the main points of this presentation are related, of course, to the title, and I just want to stress at the outset that we have a huge number of various kinds of voting procedures, and all of them have at least one major flaw, as has been shown by many, but still I would argue that all of them have some underlying motivation, the reason why they have been invented, more or less a sound reason, but anyway, they have something underlying logic behind them. But the main line of division in this literature is between those intuitive notions of winning, and that relate to the discussion that was held in late 18th century in the French Academy, Royal at the time, and that divides positional and pairwise intuitions of winning, so that positional voting systems rely on the idea that whatever candidate or alternative is winning has to be somehow related to its position in the voters' preference rankings, while the pairwise systems are just looking at the mainly pairwise comparisons of alternatives, and try to figure out the best alternative on the basis of those pairwise comparisons. And this has, I think, it still remains the basic dividing line in terms of comparative voting systems, but many attempts have been made to somehow combine these two things, because at least some of us think that there are some plausible sides on thinking things in a pairwise manner, and some of us think that the positional manner would be better. But if there is something in common, and there are some commonalities that people have tried to exploit in devising systems that would be tenable and more plausible. So I will go through some of these combinations or attempts to combine pairwise and positional intuitions, and then conclude. Can I have the next one then? This is the problem in the nutshell. So that what it means to be the best alternative. This is the simplest possible case that I can think of involving just nine voters and three alternatives. And there are three possible ways, at least three possible ways of looking for the winner. And of course, because there are only three alternatives, there can be more than that in this case. But every alternative can be made the winner by changing the voting rule. In this case, I'm listing here the preferences in the traditional manner, so that the topmost is the best one, and so on until the worst one is the listed lowest. So 4 voters have the preference ranking A, C, B, and so on and so forth. If you look at the first ranks, if people only have one possibility to vote for one alternative and they know nothing about each other, they might simply pick the best alternative, the first alternative in their ranking, and vote for that, and that would lead the victory of A. The reason being that it has the most votes. 4 people are voting for that, and 3 people are voting for B, and 2 people are voting for C. So A would be the winner in that system. Plurality runoff, on the other hand, is based on the intuition that whatever is the winner, or whoever is the winner, has to be supported by more than 50% of the voters. And in this case, no such alternative exists at the outset. So plurality runoff system eliminates the weakest runner in this first round in this case, and that's C, because it's only got 2 votes. And then the second round takes place between A and B, and in that second round, B would be the winner, because 3 or 5 voters out of 9 would support for that, presumably. And then there is this third way of looking at this thing, and that would be based on pairwise comparisons, and that would lead to C, because that defeats in pairwise comparisons all the others in those with majority votes. That is, C gets 6 votes against B, and C gets 5 votes against A. So that would be the winner. So we have 3 winners and 3 actually these are systems that are actually in use, so that there is nothing particularly artificial about this of this example. So they can lead to different things. And only one of these was based on pairwise comparisons, although you might argue that also plurality runoff is based on pairwise comparisons, because in the second round, there are only 2 alternatives. It's a kind of hybrid system, as I've called it a long time ago. So this is now I'm going to this looking at these discrepancies between these intuitions, and first going through the Condorcet extension outcomes and their discrepancies between them, because there are many of them. Condorcet extensors are voting systems that elect the Condorcet winner whenever one exists in the profile. Otherwise, they, of course, in other contexts, then they differ from each other, can differ from each other, because they are different systems. In this, this is a rather vast example in the sense that it involves a lot of voters, but 4 alternatives. Many of these examples that I have are not the simplest possible ones, although I of course appreciate always the simplest ones, because they can be expanded upon by simply multiplying the voters by the same number, and so that there are many more examples of involving more voters. But this seems to be the one that I end up with a long time ago. This is involves 29 voters, 4 alternatives, and Copeland's method, it's one of those pairwise comparison methods, that may be known to many of you, and it's simply based on counting the number of victories in pairwise comparisons. How many? You simply conduct all the pairwise comparisons and elect a candidate or alternative that beats more other alternatives than any other alternative does. In this case, Copeland method ended up with a three-way tie, A, B, and C, because all of them beat D, and in addition to D, they also beat one. There's a cycle, majority cycle among those alternatives. So in this particular case, D is the absolute loser, which is a candidate that is ranked last by the absolute majority of voters is called absolute loser. Now, Copeland ends up with this ABC tie, because there's no way of making difference between these two. Can I have the next one then? Two other Condorcet extensions, and I'm just mentioning two of them here, Max-Min and Dodgson's rule. Dodgson is something that we come back to later. Max-Min rule is based on pairwise comparisons as well, being Condorcet extension has to be. It looks for every alternative, the smallest number of votes it gets in pairwise comparisons against all the other alternatives. So that for you basically conduct or look at the k-1 pairwise comparisons if there are k alternatives against the given one, and look for the smallest, the lowest support that it gets in those comparisons, and then you pick the alternative that has this the largest minimum support. And Dodson rule is somewhat different in a sense that it's based on making changes in the preference profile, given preference profile. Dodson's rule picks the Condorcet winner if there is one. That's why it's a Condorcet extension. And but otherwise, it will look for the alternative that needs the smallest number of binary switches between adjacent alternatives in preference rankings in order to become one. That is, the smallest number of alternatives has to be switched, pairs of alternatives, to make any given alternative the Condorcet winner. And so whichever is the closest to being a Condorcet winner, so to speak. And in this example, the minimum support is 14, and that means that the D has the minimum support of 14, and that means that the Max-Min, which is all the others require more support in pairwise comparisons. D's minimum support is smallest, is the largest, and therefore it's the Dodson winner, which is remarkable in a way that this is a Condorcet extension, and one would somehow expect that Condorcet winners, Condorcet extensions don't elect Condorcet losers, but they do occasionally, and this is one example of that. And that also happens in the Max-Min system, as the minimum support, largest minimum support goes to D, which is the absolute loser. So in that way, if you compare what we saw in the last slide, namely that Copeland elects all the others but D, and these two elect only D. There's in a way, maximum discrepancy between them, because Copeland elects all those that are not elected by Max-Min and Dodson. Of course, these are not the only pairwise comparison systems, but still there's a very considerable variability between these systems. Can I have the next one, please? Positional outcomes are very variable as well. But this, and there's Don Saar is still with us here. Very good, very good. And this is his result that is referred to here. The profile is in the next slide, in fact, and that exemplifies this theorem here. I'm reading the theorem just for reference. Consider the alternative set consisting of alternatives C1 to CK, or at least 3 alternatives, that is. Then such a profile exists that alternative J wins whenever the voting rule is the vote for J, and this holds for all values of J between 1 and K minus 1, if there are K alternatives. Moreover, CK, the last one then, is the border winner. So all of these alternatives, there are such profiles that all alternatives can be made the winner by varying the voting rule among these positional outcomes. Can I have the next one then, which exemplifies this? This is also from Sari, and this involves 9 voters. And if you have possibility of voting just for one alternative, you get A as the winner here. If you can vote for 2 voting system, and B becomes the winner. And if you can vote and are supposed to vote for C alternatives, then C becomes the winner, and border winner is the D, is the last alternative there. So each one of these alternatives can be made the winner by changing the rule. And next one then, please. And then this is basically an even older observation regarding border count, which is one of the positional systems. And for those who don't remember what border count is, it's a system that gives K minus 1 points to the first rank alternatives, K minus 2 for the minus 2 for the next one, and so on, and 0 points to the last one. And then the candidate that gets the largest point sum is the border winner, and the border ranking is determined in the order of magnitude of those border scores. Now, this particular example that is exhibited there gives the collective ranking of where D is the first, and then A and B and C. Now, suppose for some reason that D is not eligible, something is found about this candidate that makes him or her ineligible, and if we simply decide not to conduct new elections, but simply determine the winner using border count in a reduced set of alternatives, then we notice that there is the complete reversal of the ranking of the remaining alternatives, which were below D. They were ranked A, B, C, and now they are ranked C, B, A. So there is the reversal of these. So it's vulnerable to these kinds of changes in the alternative set. That's I think from Fishburne's paper from '74 or something like that. The next one, please. And this one is a very old one, and that is another way of expressing the problem that we are handling here. I mean, this is according to Duncan Black, this was actually discussed by Condorcet already in late 70s, in the 1700s, and here we have a situation where we have a Condorcet winner and border winner, and they are different alternatives. And this is the simplest possible case of involving only three alternatives. If you look at the ranks here, here B is the Condorcet winner and A is the border winner. W and A have an equal number of first ranks, and they are in a sense tied in that regard. And A has more second ranks than W, and then one would expect that in fact one could say that A positionally dominates W. So in a sense that it would make sense to argue that A is even intuitively better alternative than the Condorcet winner W. But of course you can make up your mind if you like yourself. But this is a very old example and therefore worth citing, I suppose. And now next one, please. This one is also is one of the findings that made by Donald Sari, or based on that on his much more abstract and general results. But this is an example exemplifying the variability of outcomes of Condorcet extensions. We start from the original profile, which consists of 11 voters on the right-hand side, with only 2 voter groups, 7 and 4 voters. And then there's a right-hand side called Condorcet component, which is a Condorcet cycle. That's sometimes called Condorcet's paradox, where there's an equal number of voters in 3 preference ranking classes, so that every alternative is equally many times in the first, second, and third place. So that's that 12 voter profile. Firstly, looking at the 11 voter profile, there's what we call a strong Condorcet winner, an alternative that is ranked first by an absolute majority of voters. Here it's A, but we also notice that B is the border winner. It has more points than A. Very little, but anyway. And now, if we combine these two, now the left-hand side consists of voters that are, in all practical purposes, they constitute a perfect tie, because every alternative is equally many times ranked first, second, and third. So there is no way, on the basis of this information, to make a distinction between these 3 alternatives. So adding or removing this kind of group of voters from any profile should make intuitively no difference to the outcome. However, in this case, it does. If you combine this with the original 11 voter profile, we notice that in this combined profile or augmented profile, B is both the Borda and the Condorcet winner. And if you compare that with the original situation, where with only 11 voters, where B was the Borda winner, you could say that B is a much more robust winner in the sense of these kinds of modifications of the preference profile. So next one, please. Now there are a couple of definitions. I'm sure many of these are quite familiar to you, maybe all of them are. Monotonicity in fixed electorate is a property that additional support for winning candidate, lifting it higher in some voters' preferences, ceteris paribus, never makes it non-winning, so that additional support never makes any harm. Additional support in a sense of somebody changing his or her preference in favor of the winner doesn't make it a non-winner. But that's a fixed electoral property. And then another definition is a variable electoral property that's called P-top paradox. It's also called top property by Hans Peters, I think. And there are many other names. Usually the terminology is to some extent a little bit confusing, and also, but because people are using different terms to the same property. This P top, as I will call it now, is a property that says, suppose that we are using rule F that elects candidate X in a certain profile P, and assume that a group of voters with identical preferences, where X is ranked first, that is, everybody ranks the winner first in their preference ranking, joins the electorate. Again, there is variables. Nothing else changes. An instance of the P-top paradox occurs when X is not elected by F in the augmented profile. That is, the additional support in the sense of a voting group apparently favorable to X joins the electorate. Then X is no longer the winner. It is somehow, at least at first sight, looks perhaps a little bit surprising, but these systems occur. These systems exist. The next one, please. Another one is a kind of mirror image of the P-top properties, P-bot paradox. Suppose that Y is elected by rule F in a profile P. Assume that the group of voters with identical preferences where Z, that is something different from Y, is ranked where Z is ranked last, joins the electorate ceteris paribus. So in this new group, there's they have alternative Z ranked last in their preference rankings. An instance of the P-bot paradox occurs when Z is elected in the augmented profile. That is, the people who are joining the electorate, who all rank Z last, get their last ranked candidate elected, while otherwise, if they hadn't been active at all, something else, something better for them, namely Y, would have been elected. This is also known as the no-show paradox. No-show paradox is one of those concepts that are used in somewhat different senses, and I'm not innocent of that myself. But anyway, this is just the original, at least insofar as I think it was presented in the 1983 paper by Brahms and Fisber. And finally, the participation. Joining the electorate and voting according to one's preferences never harms a voter when compared with the outcome obtained without the voter's vote. So participation should do no harm, either in the sense of P-bot or P-top or some other ways of milder way. So that participation also always is sensible when compared to inactivity in elections. That's what participation says as a condition satisfied by some systems and not satisfied. And one of my points here in this that these properties basically are such that they are usually associated many times associated with Condorcet extensions. While not so often in positional voting systems. Next one, please. Now going to these bridge building efforts of combining these two intuitions of positional and pairwise intuitions of voting. Black, who was already mentioned, is perhaps the first one who tried to combine these two. And this is an example showing that his procedure is vulnerable to the P-top paradox. That is additional support in the sense of a group of voters ranking the winner already first, when joining can make it a non-winner. This is Black's system. To remind you of that, this is a system where Condorcet winner is elected if one exists. Otherwise, the border winner is elected. So that's an obvious way of, perhaps a little bit sort of a straightforward way of trying to combine these two intuitions. In this particular profile in the table, no Condorcet winner exists, and therefore border winner is elected, and that's E. And now if we suppose that two voters with the ranking A, B, A, D, C join in, and now the Condorcet winner is existing in this augmented profile and therefore is elected, and the Condorcet winner is D. That is by joining these two persons and voting for the winner by expressing the first preference for this winner, they make it a non-winner. So this is an instance of P-top paradox. Next one, please. This the example showing that the Black procedure is vulnerable to the P-bot paradox is simpler in the sense of involving only 7 and 8 voters. In the original profile, there is a Condorcet and Black winner because there's an absolute winner in this strong Condorcet winner on the left hand side, and that's therefore elected. And if we now suppose that this one voter with ABC ranking joins in, then the Black rule elects C in this new situation, and that shows that by staying at home would have been better for these two voters. For this one voter, sorry. And next one, please. Nansen is a relatively sophisticated system, and I think rather clever in that sense. It was already proposed in 1882 or 83, depending on the source one is studying, by A.J. Nansen. It's an explicit attempt to combine Condorcet and positional winning intuitions. It utilizes border scores in eliminating candidates until a winner is found. Based on the observation that there is a connection between the Condorcet winner and border scores that works, the Condorcet winner, while not necessarily the candidate with the largest border score, has always larger than average border score, and that's a useful information in using in this elimination process. And by eliminating candidates with at most the average border score, one guarantees that the eventual Condorcet winner is not eliminated. There is another one which I'm not mentioning here explicitly, but called Baldwin's rule, and that is based on 1-by-1 elimination of candidates, with the smallest border scores. This is Nansen's method is older, and it's also more efficient in a sense if one is just looking for the Condorcet winners. But other than that, there are not major differences between them, and the intuitions are pretty much the same. Next one, please. The Condorcet winner choice is a property that you may like or may not like. But anyway, if you like it or if you want to achieve it, then that comes with the price. And so For example, there are a couple of things that I'm mentioning here. Nansen's method is not monotonic. Usually you need a relatively complex example to show that. That may lead to this. This is sometimes called a more is less paradox. I think Fishburne and Brahms used it, and also a British mathematician, Woodall, I think, uses the same term. Additional support for the winner ceteris paribus may turn it to non-winner. And Nansen is also vulnerable to both P top and both P bot top and bot paradoxes. Next one, please. There are several slides now detailing how this can happen. Nansen fails on monotonicity here this is a massive example. I would say that in a sense that I'm not particularly fond of it because it involves so many voters, 43 voters, key alternatives. Anyway, yeah, Nansen works so that the first D and then both B and C are eliminated, and then A becomes the winner. Now, if we are supposing that the first leftmost 5 voters increase A support by changing their preferences to A, B, C, D, that is thus lifting A first, and everything else remains the same. Then in this modified example, then B and D are first eliminated, and C then finally becomes the winner. So that fails on monotonicity, this one. Can I have the next one, please? And B top is exemplified here. The P top paradox here C wins under Nansen's method, and then if you add new voters, just one of them needs to be added with the CBA ranking, that is C is the former winner, then the augmented 19 voter profile changes so that B is the Nansen winner. So illustrating the P top paradox. Next one, please. And B bot is similar, but of course the mirror image of the latter. Nansen method here results in B. If one voter with the DABC ranking joins in, and then the new winner is C. That is the last ranked alternative of the joining voter, which is what happens in P-bot paradoxes. Next one, please. Then I already mentioned Dodson, and I should add now in this context that Dodson's associating Dodson's name with this procedure is perhaps not completely accurate, and maybe because it doesn't have many good properties, but therefore it's somewhat unfair to him because he suggested a number of systems. And I think he would have been just thrilled to see all these paradoxes related to that, because he was a man of paradoxes, and he really liked them. All kinds of funny things that can happen when we are using voting rules. But this seems to be a standard practice that this procedure is associated with his name, and so I'm stick to this practice, even though I have some reservations, and many others have reservations as well. It is non-monotonic in fixed electorate. It's also vulnerable to both B-bot and B-top paradoxes, and it makes the choice of absolute loser possible, as we already saw in the circumstances where Copeland on the one hand and min-max or max-min and Dodson resulted in the absolute loser. It is also non-homogeneous, a property that hasn't been touched upon very much in the literature, and because it's a rather rare property, but it doesn't mean that it would not be interesting. But already in 1974, John Smith, in his classic paper, characterized non-homogeneity and its significance by saying that homogeneity seems extremely natural requirement. If each voter suddenly splits into m voters, each of whom has the same preferences as the original, it would be hard to imagine how the collective preference would change. And this is precisely what can happen in Duchenne's procedure. Can I have the next one, please? That is non-homogeneity of Duchenne's rule. Here we have an example. This is not my example. It's Felix Brandt's example involving 12 voters and k alternatives. Here A is the Duchenne winner, and if we consider a profile where the size of each group of voters is multiplied by 3, in the ensuing 33 voter profile, candidate D requires the smallest number of reference switches between adjacent candidates to become the Condorcet winner. And that's non-homogeneity. And next one, please. Okay, now I have to ask you, do you think that you are bored enough already? Because I have a few slides, but if you are ready to go to the conclusions, then I can do it. But if you think you can, well, okay, I'll go through them and please feel free to leave if you don't like that. This is a somewhat more recent way of building bridges, and that's an explicitly expressed target of the authors, and that's why I think it's worthwhile to go through, because the previous ones have at least started from the assumption that if you are trying to combine two intuitions, then you at least have to achieve one of them, and then try to go as close as possible to the other one, in a way of like, for example, if you don't get the Condorcet winner, you will as close to Condorcet winner as possible, or in the case of black, and so on and so forth. They are all based on the idea that at least one of these intuitions is fully satisfied. Now, this has the specific property that it doesn't necessarily satisfy either of them, which makes it kind of in a way funny. But it's still done by a very topmost, top class scholars, and it's a very serious effort. And they have a number of other papers later than that one that I'm referring to, and to show that this is work in progress more than anything else. We start with some definitions. Supercovering is the basic concept here. We use this denotation that N of A and B denotes the number of voters preferring A to B, and individual preferences are strict, as we have done all along in this presentation. We have not complicated things by assuming individual ties or things like that. A supercovers B if N of A and B is larger than N of B and A. That is, against the pairwise comparison between A and B, A gets more votes than the B gets. And furthermore, N of A and X, that is some other alternative on the B, is larger than or equal than N B of X. That is for all of the other alternatives rather than B and B. And then A has at least the same majority, the vote margin in its favor than B against any other alternative. That's supercovering in the sense of these authors. I'm just mentioning their name because I put it in the wrong place. Then they defined the pairwise winner, and that A is the pairwise winner if it supercovers all other alternatives. It's a kind of related concept to Condorcet winner. And the unsupercovered set consists of alternatives that are supercovered by no other alternative. That all, it's like covering relations in a tournament theory. It's very much motivated from those. Next one, please. These are the authors, Perez, Fernandez, and De Weitz. and their solution concept is p-optimal alternatives. P-score of the alternative measures the distance from being the pairwise winner. That's a distance-based choice function, as there are many others. Many systems can be represented like distance minimization. P of A tallies the number of pairwise switches on A's row. That if you have this pairwise comparison matrix where each alternative is in a row and in the column, and A row consists of the numbers that represent how many votes A gets against all the other alternatives, and B, and so on and so forth. P of A tallies the number of pairwise switches in A's row that are required to make two things. One, n of A and x greater than n x of A. That is, x wins in a majority sense all other alternatives in its row. And furthermore, to make n of y larger than the maximum over x of n of x and y. That is, in each column of its row, the A's entry is the largest. And p-optimal alternatives are those with the minimum p-scores. That is, minimum in the sense of how many changes will have to be, how many changes in numbers have to be made in order to satisfy these two conditions. Now a couple of examples. Next one, please. Some properties. P-optimal alternatives are always unsupercovered. No alternative supercovers them. That's I suppose, the basic motivation of that. If a pairwise winner exists, it is the unique unsupercovered and p-optimal alternative. P-optimal alternative may not coincide with the Condorcet winner, not even with the strong one. That is, of course, a disappointment for those that who expect that this would be actually a bridge between two inducers. But even worse is that p-optimal alternative may not coincide with the Condorcet winner that coincides with the border one. So that in that sense, it's a bridge that it stands on two pillars in the middle of the river, but it's not connected to either bank of the river. Here is a very simple example. We have the 13 voter profile on the left, and then there is this pairwise comparison matrix. And then the next column with the B-score column indicates the Borda scores, which mean that that Borda's winner is A, and the p-optimal alternative is singled out here. It needs only that the smallest number is required for the win, and that's the Borda, the number of changes needed for making B the p-optimal alternative is the smallest. It's only 3 switches that are needed there. So they are not coinciding there. Next one, please. Now there's this bizarre twist, non-homogeneity, and that is in fact it's discovered by the authors themselves, and this is the situation where we have A, B, and C, because they have this the P scores, that is the p-optimal scores, smallest p-optimal scores. They all have the same p-optimal scores, namely 3. And now look at the profile which is obtained by multiplying by 2 the voter groups there on the left, and we get the next one, please. And now we notice that there is only one winner here. It's the A that becomes the p-optimal alternative. So it's not it's not homogeneous voting procedure, which means that basically, if you are looking for a system that would be generally applicable, then you would have to, you would basically have to take into account the number of voters in order to look for that, and that of course is somewhat bizarre. Next one, please. Now we have finally come to the conclusions. Binary and positional ideas of winning are fundamentally irreconcilable. That probably has been known before, and hopefully is reasonably clear after hearing this. Then the strive for controls and winning outcomes comes with a high price in terms of properties such as participation. One has to sacrifice in achieving them. There's Eros Theorem, which says that all control extensions basically fail on participation. I didn't mention that theorem here because it's I'm just mentioning that because that's one of the major theorems here. So that if you want controls and winners always elected when they exist, then you have to make do with situations where participation fails. That is, it may do harm for a voter to vote. And then instead of evaluating voting rules in terms of choice theoretic desiderata, one should perhaps shift focus to the effects of choices. And this is something that has been done by many of you, and I'm definitely not an expert on that, but I think I sort of share the idea of plausibility of that. Assuming that no system is good in all respects, then one should look for other properties that might make the difference in whether they show division and conflict, or do they encourage consensus and cooperation. Might be values that one would like a voting system to foster or at least promote. And do they? One of the practical things that is very important is that do they result in decisive outcomes, or do they necessitate further fine-tuning of outcomes through negotiations? And that, of course, is often happens when we have systems that often end up in ties of some sort, and then the actual decision making has to be relegated to some other body or some other institution. Without mentioning it, I started, in fact, with Riker's book that this year, I think almost to the month, is celebrating its 40th anniversary, Liberalism against Populism, where he challenges, first wanted to challenge all the political scientists, but then the wider community of social choice scholars by arguing that in the end, if you look at the voting procedures that exist and the properties that they might have, you cannot escape the conclusion that they all have such a serious flaw that there is no way of associating anything resembling collective will of people's will with the outcome. So the only thing you can hope for is that and democracy needs is that there's a way of organized way, a periodic way of getting rid of your rulers. But that's of course a very pessimistic view, and I for one was very strong, was shocked by it first, so that of course even though all systems have their flaws, some flaws are more serious than others, and at least one should try to look for systems that have as few flaws as possible. Then next one, please. I just want to mention a couple of sources. Black's book is a classic, and the next one is not a classic, but it's where a couple of these examples were obtained, and Liberalism against Populism by Riker is the one that actually prompted this whole idea. And next one, please. And then a couple of books by Sari, and especially the latter one, Disposing Dictators, Demystifying Voting Paradoxes, looks almost subversive, but it's a very important book and so topical. But it was published already 14 years ago. Anyway, it's not directly applicable to current situations. And then we have some classic articles. Brandt's book, and here I should mention Chaotic Elections, which is a more mathematical and technical text, and definitely a worthwhile book to read. And then Dodson rule is very nicely analyzed by Felix Brandt. Fishburne's control social choice function is also quite well-known article. And I think I have a couple of more slides yet. Next one, please. Yes, and there's this Boolean's article, Condorcet principle implies the no-show paradox. No-show paradox here is a violation of simply participation. And the last one is contains the Perez-Fernandez and the Bates' papers reference. So I think that was what I had in mind. I'm very sorry for this technical failures on my side, and I try to learn more about the system for future.
So thank you very much, first of all.
Thank you.
Thank you.
Yeah, thank you very much, Hannu. And thank you for the presentation. And I also want to thank Per Molander for the introduction. It was quite a substantial introduction in the field, and it was, I think, a very good start. Let's start with the discussion. Questions to Hannu and Per. Now, I have an observation, if nobody else wants to talk, about this general will, you know, and the problem with the Riker pointed out. There is already something in Eros, you know, he refers in the text part and later in the, I don't know, page 100 on the general will. And what I understood is, you know, the general will means, you know, there is already a general will. And you cannot create it by voting. You cannot say that a voting outcome is now the general will. But the idea of error, I think, in this text part is, you know, that he says, well, if many people have this kind of preferences, you know, then we can find it as an idea. So in his term, there was not a real conflict because, I mean, the impossibility or possibility theorem wouldn't be any problem if you have 95% having the same preferences. I think this was kind of in the air there. What do you think about that? I mean, if then the Riker problem is not there anymore, you know.
I don't recall what Arrow wrote about this, but it may well be. But this general will, I think, is at least as such is not probably even mentioned by Riker. He thinks about, he says will of the people, because that's his title says that this is a liberalism against populism, and I think that populism is the idea according to which voting outcomes somehow reflect the will of the people, and he thinks that that's nonsense. It cannot be the case because all the voting as such plausible voting rules can result in different outcomes. So how in the earth they can all represent the will of the people? And also his idea that there are so little circumstances or few circumstances, maybe he's where people benefit from misrepresenting their preferences. So the strategic voting, what is the real preferences and what are the strategic preferences, how to come in terms with these. I think these were the sources from which he derived this rather pessimistic conclusion that we have to look for some other functions of voting than just the content of it. So that the main rudiment that has to remain there in order to save the liberty, so to speak, is the possibility of getting rid of the lulus, send the rascals packing, as the British say, I think. So that's, I think, how he thought about it. But as I said, I was in fact, I was already trying my hand of these things at the same time. Of course, not in the elegant way as he did, but I was shocked by it because I thought that there are better and worse systems. But little did I know that there are so many other properties that had not yet been discussed. These kinds of participation-related properties and all the consistency type of properties. Consistency is dealt with Riker, but there are so many others that have been dealt with. And so, yes. But this general will, I think, is. Yeah, Fuad, please.
Yeah, thank you. Hannu, first of all, thank you very much. Very interesting talk. And you see, what is your view? In fact, you see, with this, your and Don's work and others, and we have multidimensional, let's say, representation of voting systems, including this non-manipulability, or, well, not non-manipulability, the degree of manipulability of voting rules, and also the informational complexity of voting rules. I always tell students that, you see, the deficiencies of plurality were known even to ancient Greeks, but they still used it because it's informationally very simple. You see, you can explain it to everybody. Which is rather, and other rules, rather, especially, you see, the rules which came at 19th century, it's rather difficult to explain to usual people, you see, to laymen. What do you think about, you see, what is your view to this all multidimensional situation in this field? Thank you.
Thank you. Multidimensional thing, you mean that the alternatives have multi-dimensions, or
I mean
systems have
systems,
multidimensional
paradoxes, manipulability, informational complexity. If we consider this all together, you see, we have really multi-dimensional evaluation of the system. If we consider the rules in this way, angle.
Yeah, I'm not quite sure of that. I get the idea, but the for example, the manipulability that you mentioned, and where you have done much work yourself, is manipulability is certainly an important property, and how much information you need to successfully manipulate, and how much additional assumptions you have to make regarding the others counteracting your manipulation and stuff like that. That makes things. It makes the voting actually became a strategy, and which is, I suppose it is in boardroom votings and things like that, where people are somewhat knowledgeable about others' preferences, and then they try to adjust their own behavior so that the outcome would be as good as possible for their own point of view in terms of their real preferences, underlying real preferences. I think it's a relevant factor, and if one thinks about the elections, real world elections, plurality being the predominant in British speaking world, I suppose, the idea of getting getting the people to vote sincerely or according to real preferences is somewhat questionable, because there you usually know from the opinion polls and stuff like that if you are, for example, a small party supporter, and that you know that the main contestants are two big parties, then you probably would vote for the least, the most tolerable one candidates, even though you don't particularly like the candidate, but you like it better than the alternative. Plurality runoff is another one where you can where you can easily find situations where people are trying to manipulate the candidates to the second round by simply ignoring the small candidates, even though they would like them most. And so I suppose manipulability is successful manipulability requires different sort of information by the voters. Sometimes it might even backfire. So that if you are misrepresenting your preference, you might end up with a voting outcome that is worse than the sincere voting might have been. So that it's a tricky thing. I don't really know what to say about that, but that's one of the dimensions, of course, and that's one of the things that I hinted at, even though I didn't mention it in those other. When trying to look for other values than those social choice value type of criteria, that might be useful to take into account of how much information one needs to in order to manipulate successfully, or how much information one should divulge in order to behave in a way that would regard it acceptable. Systems vary in that regard. That, of course, that you knew. That's a trivial observation, but that's all the thing that I can say in this.
Thank you.
Yes, Peter. Is it Peter?
Thank you, Hannu. Very, very interesting, and I very much enjoy your quotes on William Riker. And I'm going to refer to what Per Molander said at the beginning in his introduction. And he said, when there are only two alternatives. But Riker said, simple majority decisions cannot be fair in a democratic sense, because the imposition of binary alternatives is itself unfair. And we saw this in Crimea, where Putin decides that there are two alternatives, and the Crimean Tatars boycott. I mean, there's no alternative for them, so what else could they do? And it's very similar to what happened in the Brexit vote, when Boris Johnson decides that, or David Cameron rather, decides that we're going to have remain or leave. But it was a multi-option debate, and to have a two-option choice on a multi-option debate is surely just a nonsense.
Yes, I agree. And I think many people agree with you on that. So that you can only make sensible choices or reach sensible outcomes if you can choose from sensible alternatives at the beginning. So agenda control is a very important factor in all these things. But the question, of course, is that what would be the good instrument in generating sensible alternatives for to be subjected to voting? That's a tricky thing. I think there are, and in fact I was originally planning to present the presentation on deliberative democracy kind of movement, where the idea is that people would be actually discussing the alternatives before they actually vote. The voting would be the last stage, and they prefer the outcome that would be reached without voting at all. I think that avoids some problems perhaps, and because deliberative democracy starts from the citizen juries and mini publics and institutions like that to determine the actual voting alternatives, but then that again makes it applicable only in a relatively small communities, because otherwise you might end up with the aggregation problems. Aggregation paradoxes are all over the place. You have to combine these outcomes from various mini publics or citizen juries in order to come up with something like a global solution to the issues at hand. I think this is something that it's very actively advocated, and there are some top-rate political scientists involved in this. But of course, I'm always a little bit skeptical about everything that seems to solve all the problems, and this seems to be the case here as well. But I have written something rather preliminary, but that was not presented here because some of those claims that have been made in those contexts are pertaining to the things that they by resorting to citizen juries, they might be inherently able to avoid theorems like Gibbard-Sadet weight on strategic voting and Eros Theorem on aggregating preferences, which I think is a nonsense, because they are basically what they are doing is the domain restrictions, and the results remain the same. They are mathematical results. They are not based on but their argument is that that these deliberative bodies somehow restrict the domain of discussion, and this has been very much supported by others who think that our results generally, not our, but those who are doing results, Fuad and Don, for example, they are general results, and some people, I think what we would need is domain restrictions that would be we need results that are applicable in certain domains, like single peaked ones, to name one.
Okay, sorry. Don Sari has a comment since long.
Oh, I'm sorry. I'm just rambling on, you know.
Very fine, but he's sitting there already 5 minutes or 10 minutes.
Oh, I'm sorry. Yes. No. Okay. Please.
Okay. A couple of things. First of all, I enjoyed your presentation with a large number of thoughts and everything else. Of course, one of the questions that we want to know is why? Why do these paradoxes occur? What causes the paradoxes? For example, the no-show paradox, or the paradox of participation paradox, and all of them, they're all due to the fact that we have several voting systems. And what you're doing is you're choosing who. If I decide not to vote, then what happens is if I vote, then maybe Anne and Barb will be compared in the runoff. If I don't vote, then Connie can get there, and Connie can beat Anne. And so what happens is it's just as the politicians are well aware, be careful of who gets in the runoff. And because that's the no-show participation paradox, etc. And it'll happen to anywhere where you have a filtering to filter off one for another. The second comment is the ones you were saying about Eros Theorem. Eros Theorem, really, if you take a look at IIA, what IIA is a filter. What it does is it says that if you cannot rewrite your voting rule as paired comparisons, then it doesn't satisfy IIA. It's if and only if. So therefore, Eros Theorem is not a statement about universal statement about all voting rules. It's a statement that be careful when you use paired comparisons.
Yeah.
A third one is your comments about, and I think I learned this from Maurice Stahls, but your comment about deliberation, etc. And I think Maurice is the one who told me that, and then I checked and found it's true, that the that Condorcet, that there's two parts to Condorcet's type of result. And the first one is really deliberation. You can have the darn good voting system, but people don't know what they're voting on. It's going to be very, you're going to have horrible outcomes no matter what can happen. And in that fashion. So really, those are the only comments that I have. But you know, going back to the multi-dimensional comments, yes, you have n candidates, and we are in an n factorial dimensional space. There's so many different kinds of ways we can rank things. And so the question is how can we manipulate that space? And for that, you really have to understand what causes paradoxes and why do they occur. And when we understand what causes paradoxes and why they occur, we can start getting sharper and more comfortable results.
Thanks for the comments. This is a profound question. I mean, very good points, all of them, but a particularly profound question was raised by this: what causes the paradoxes? And that also gives us a kind of idea of how often one might expect to encounter them in practice, if that is anything I mean, of course, you can always ask whether these kinds of things that only can happen in very peculiar circumstances, whether they have any practical importance at all, or whether they are just mathematical curiosities, or not even mathematical, but curiosities. And so this is a profound point. And I know that even though I have not been involved myself in it, and there's a lot of research going on regarding finding out what happens to the paradox probabilities under various kinds of environments. So I know that, yeah, and I'm sure Maurice knows much more about this than I do, and there are a lot of other people who are doing this kind of work. But there is always these cultures. They are doing simulations or probability models in various kinds of cultures, making assumptions of what kind of preference distributions exist, and then look for these kinds of things. I'm sure you are looking for something more profound regarding the emergence of paradoxes, but this is how it seems to be approached these days. Did Per have a... Yes, please, Per.
Yeah, well, it's just a follow-up on this. I had a remark or question going in precisely the other direction. I mean, when Arrow showed his impossibility theorem around 1950, it was not long before Black came up with this example showing that if people's preferences can be graded along a left-right scale, the impossibility disappears. So obviously the distribution of preferences is critical to the emergence or non-emergence of these paradoxes that we spend so much time on. What I was interested in hearing, are there any theorists working with real preference profiles? I mean, things you could extract from surveys or voting outcomes, etc., so that you could marry empirical political science to this basically mathematical body of research.
My answer to that is that I know that there are some results, and I recently reviewed a book edited by Mostafa Dis and Vincent Merlin on it's a large collection of articles regarding these kinds of simulations, but there were very few empirical works there. Another thing that I have encountered in my long correspondence with different people pertains to alternative vote, or STV, which is a system that is being used in parliamentary elections in Ireland. And because that's where you get the data on preferences. Usually you don't get the data on preferences other than in opinion polls. But there have these ballot papers, as correct me if I'm wrong, Peter, But there you get the ballot papers where you are simply indicating your preferences. And that's how you can actually make empirical estimates regarding the paradox probabilities. When I tried to, in vain, convince the Electoral Reform Society that alternative vote or single transferable vote is not without serious faults itself, that it's one should at least temporarily look for other alternatives as well. They came up with an answer that there were election officials who told me that even though these kinds of no-shows and other things that I was mentioning are simply do not exist, they have the firm information about that. They don't exist. They are very rare. They have found 1 or 2 districts where over 100 years or something like that. Of course, I can't argue with that, but maybe. But it's surprising how little has been done on actually estimating people's the distribution of preferences, especially in systems where people are just casting one vote, and then usually you make estimates regarding the probabilities by looking at by constructing the preferences on the basis of some sort of distance measures. In Britain, they have done, I think already in 70s, they tried to estimate the probability of encountering what they called Bordas paradox, that is of electing a candidate that is lowest ranked in the district. Pountney and Coleman, I think, were the authors, and they were basing their estimates on opinion polls on various districts regarding the second-ranked and third-ranked candidates for those voters who vote for one candidate, and so there are very few studies. There are very few studies that I know of, but of course it's serious restriction to say that it's that I know of, but I haven't encountered. Sorry about that.
Mm-hmm.
Can I come in again? Because
Yes.
I stood as a candidate in 15 PRS-TV elections here in Belfast, and I regard myself as Northern Ireland's most successful failure. There are several quirks with PRS-TV, as you know, and one of them is the fact that if you are the most brilliant second preference of everybody, you get a score of 0 and you're out, and nobody ever knows that you've got all these second preferences from everywhere. But one of the, interesting to hear your comments about the Electoral Reform Society. They are pretty adamant that PRS-TV is God's gift to the human race, and that any other discussion, like Michael Dummett's quota border system, and they won't even look at it. And the thing that was really distressing was when we in the United Kingdom had a referendum on our electoral system in 2011, and David Cameron, that we decided that we would have a choice between his first preference of first past the post or his second preference of the alternative vote, and anybody else's preferences were not allowed to be on the ballot paper at all. And the thing that was quite extraordinary was that the Electoral Commission decided that this was fair. And when mentioning to them the fact that when New Zealand had their referendum on their electoral system, and as everybody knows, I'm sure they had an independent inquiry which the political parties were bitterly opposed to, but this inquiry just got ahead and produced the 5-option ballot. Oh, jolly good, and a bit of choice. But it wasn't even referred to by the Electoral Reform Society. They just wanted PRS-TV or yes or no, and when it was AB, yes or no, they went along with that as well. So preference voting in elections, oh yes, they're madly in favor of that, but preference voting in decision making, no, it has to be a majority vote. Quite extraordinary.
Yes.
Any comments on that? No. Well, if not, then I think we should close the session and thank the speaker and Molander for the introduction, and of course all those who gave and those who didn't. For everybody, thank you.
Thank you very much.
Um,
Thank you very much.
We see
Patrick,
next week.
Thank you all for coming,
Okay.
and sorry
So-
about the mix up with the slides.